Hello learners, welcome to this session. The topic for discussion in this session is embedded operating system and requirement specifications of embedded systems. I am Professor Subrahmanyam, Director, School of Computer Information Sciences, IGNOU, New Delhi. In our earlier session, we have seen about the introduction to embedded system, their applications, and we have seen several examples wherein which the embedded systems were used. In this session, let us concentrate on an important component, that is the embedded operating system. Before going and learning the embedded operating system, let us concentrate on what are the basic differences between the general purpose computers and the embedded systems. So, coming to the general purpose computers, it is designed using a microprocessor as the main processing unit. In the embedded systems, we have learned that microcontrollers will be used, and this particular system we can't treat it as a full-fledged system. However, these are meant for a special tasks. The general purpose computers contains a large memory, that to semiconductor memories like cache, RAM. It also contains secondary storage like hard disk, etc. And in embedded system, it uses semiconductor memories but does not require secondary memories like hard disk and CD. It sometimes has special memory called as the flash memory. So, in most of the embedded systems, we may use the flash memories. General purpose computers are designed such that it can cater to multiple tasks as per the requirements, and in the embedded systems it is just designed such that it can cater to a particular predefined task, and it requires huge number of peripheral devices and their controllers in the general purpose computers, and in the embedded systems it is cheaper as it requires less number of peripheral devices and their controllers are microcontroller chip itself. In the general purpose computers, the operating system and other software for the general purpose computers are normally complicated and occupy more memory space. But when you take the case of the embedded system, the RTOS, that is real time operating systems in many cases, and other software occupy very less space. Let us throw the focus on embedded operating system. So, this particular embedded operating system is an essential component for any embedded system. So, it is a specialized operating system designed to perform a special task for a device that is not a computer. So, whenever we talk about the operating system, it is nothing but an interface between the user and the system that we are using. So, here also embedded operating system will act as an interface between the embedded system and the user, or else you can call another user interface wherein which it wants to take the outputs from the system. So, in an embedded operating system, the main job is to run the code that allows the device to do its task. The embedded operating system also makes the device hardware accessible to the software that is running on the top of the operating system. So, in these operating systems, what are the main functions? In the general purpose operating systems, the main functions are process management, memory management, device management, file handling, error handling, security. All these are the main functions of a general purpose operating system. In the case of embedded operating systems, some of the functions always exist. However, that depends upon the system that it is working with. It is normally guarantees a certain capability within a specified storage size and time constraint, as well as with the application programs. So, its structure is very similar to that of a normal operating system like any Windows based or Linux based operating systems. However, mainly differentiated by certain factors such as pre-installed device, functional limits, taking design job only. So, if at all the embedded system is only meant for only a single task, the operating system behind it may be having a very limited functionality, taking a single job designed and meant for it. So, it also normally has a bootloader, operating system kernel, required device drivers, file systems for the user data and so forth. At their core, embedded operating systems contain some of the same software components used on larger operating systems such as Windows and Linux, etc. Larger operating systems like embedded operating systems deals with the task switching, schedule of tasks, memory management, etc. So, let us take the case examples of some embedded operating systems or else embedded systems itself. So, examples include computers in cars. So, there may be several embedded systems in the cars also to look and monitor the activities of the cars. So, like the braking kind of thing, fuel kind of thing, or else whatever the case may be. There are several embedded systems embedded in the car in order to look, monitor several activities, and if at all there is some sort of abnormal parameters or abnormal things happening, immediately it will allow the user to know the things and take appropriate action. It may be the user or else it may be the driver to take care of the things, or else it may be another system which will be taking care of the immediate action or immediate response that needs to be taken care. So, examples include the computers in the cars, traffic lights, digital televisions, ATMs, airplane controls, point of sale terminals, digital cameras, GPS navigation systems, elevators, digital media receivers, smart meters. So, there are several examples which we can quote. Even in the earlier session also we had seen several detailed examples, and we had known about the embedded systems. So, let us take some examples of embedded operating system. Many modern electronic devices are based on Arduino or Raspberry Pi. So, whenever we talk about the Internet of Things also, these particular two things we frequently hear. One is the Arduino and other is the Raspberry Pi. The Raspberry Pi devices often run on ARM based Linux kernel, but there are actually a number of different operating systems that can be run on Raspberry Pi devices. So, Arduino devices have a much more primitive embedded operating system that acts as little more than a bootloader and a command interpreter. So, how this embedded operating system works? So, when we take the case of a general purpose operating system, as we had heard that there are several functionalities that needs to take care by the operating system, like the memory management, process management, device management, IO handling, interrupt handling, then error handling. So, whatever the case may be, there are several things that needs to be taken care by the operating system. Even in many at times we call the operating system as the resource manager or else the overall manager of the computer system. But when we take the case of the embedded operating system for the embedded systems, it is just in contrast to an operating system for a general purpose computer. It can be quite limited in terms of functionality, and it will be serving only simple tasks that it is meant for. However, that single application is crucial to the device's operation. So, an embedded operating system must be reliable and able to run with constraints on memory, size and processing power. When you take the case of the embedded systems, they come in very small sizes. In case of memory, in case of size, in case of processing power, in case of the battery power that it is using, whatever the thing that we like to focus upon, the embedded system is a very small device when compared to a big general purpose computer. An embedded operating system allows the device to do its job. In the case of Raspberry Pi, for example, an SD card, you can see these particular SD cards are embedded on our mobiles also. So, this SD card acts as the device hard drive and contains the code that runs on the device. Because the SD card is removable, its contents can be modified on demand. So, because the embedded operating system makes the device's hardware accessible to the application that it is running on the top of the operating system, hardware components such as USB ports and HDMI ports can be leveraged by the applications running on the device. So, let us just see what is the basic difference between the embedded and the non-embedded systems. An embedded operating system is integrated into a device, and depending upon the device, that it may also reside on a chip. As we had seen in the previous slides, most of the things resides on the SD chip. Embedded operating systems tends to be limited in scope with regard to what they can do. In contrast, a non-embedded operating system tends to run from a hard disk or an SSD. So, when you take the case of a general purpose computer and if it is in the switch off state, so the operating system like the Windows or Linux operating system, it resides on the like hard disk. Whenever the booting process is on, obviously the next step is that it will be the whole operating system will be landing onto the RAM. Here you can see this particular embedded systems have a little scope and they may reside on a single simple chip. Non-embedded operating systems such as Windows 10 or Mac OS tend to be user configurable or upgradable, and they are usually designed for general purpose use. And these embedded systems, because of their limited usage and limited functionalities, they may not be allowing us to upgrade or else to reconfigure. So, coming to the characteristics of the embedded operating systems, it has main characteristics as listed on the slide. One is direct use of the interrupts. So, there may not be any mediator which will be taking care of the interrupts. However, it will the embedded operating system will be directly taking care of the interrupts. And then reactive operation. So, whenever some trigger is happening or else some event is happening, eventually it triggers the relevant and reactive operation. And then the operation whatever that it triggers is the real time operation depending upon the characteristics or depending upon the parameters that is eventually monitoring. Obviously, when there is a abnormal thing happening, then reactive operation or else the real time operation will comes into picture. Streamlined protection mechanisms are available in the embedded operating systems. IO device flexibility is there and not much like input output devices. Whenever we talk about the along with the embedded systems, a very little IO interface is required because we do not connect like monitors and other kinds of things. There may be a simple and a very little bit of IO interface is possible for the embedded systems. And coming to the configurability, there are various configurations that we can see depending upon the embedded system, the functionality, the task that it has to handle, the embedded system is being configured in such a way. So, coming to the classification of embedded operating systems, they are classified into two kinds of embedded operating systems. One is the real time operating systems and the other is the non-real time operating systems. The name itself says whether it is a real time response or whether it should be a non-real time response. So, depending upon this particular basic underlying word, the function or the classification has been done. Let us see what is a real time operating system. So, a real time operating system is the one which serves real time applications. So, obviously, whenever the real time word is there, the immediate we will be looking for the immediate response or else immediate reactive operation. So, these particular immediate reactive operations are possible using the RTOS. It processes data as it comes in. The time requirements for processing of operating system are usually measured in shorter increments or in the 10th of the seconds. So, you can see here whenever the monitoring is happening on the shorter increments or in the 10th of the seconds, so obviously the reactive operations will be happening. Suppose if the reactive operation does not happen, there may be a disaster also, or else there may be an accident in a car, like in the cars or in the industry. Suppose if they are being used for the industrial uses, then there may be a hazard happening in the industry also. So, there may be time sharing or driven by events. Real time operating systems are used in small embedded systems which requires immediate responses. So, let us see the features of the RTOS. The main features of real time operating systems includes process threads that can be defined, multitasking is possible, high level interrupts happening. So, until and unless high level interrupts or else immediate attention needs to be focused upon this particular RTOS, once again we may not call them as the real time. If you take the case of the real time operating system examples, VS Works is a very prominent example we can quote upon, which is a real time operating systems, works in many of the embedded systems. OS 9, that is operating system 9, is another real time operating system. Symbian is another real time operating system, and RT Linux, that is the full form is real time Linux, is there. This is the open source software wherein which it takes care of the real time happenings of the Linux operating system. So, coming to the types of the non-real time embedded operating systems, there are several to quote. One is single system control loop, second one is multitasking operating system, rate monotonic operating system, preemptive operating system, microkernels, monolithic operating system. So, here I had given only 6, other than these 6 there are several, like another 4 to 5 non-real time embedded operating systems are available. But these 6 are very prominently used depending upon the functionality, depending upon the usage in the applications. These are categorized into many, however these 6 are very prominent. First one is the single system control loop. Single system control loop is the simplest type of embedded operating system. It is so like operating system, but it is designed only meant for a single task. So, this particular operating system will handle only one task. It is still under debate that this system should be classified as a type of operating system or not, because it is having a very limited functionality. So, people are thinking that whether to classify this as an operating system or not. Next thing is the multitasking operating system. As the name suggests, this operating system can perform multiple tasks, and this is in contrast to the earlier system that we had talked about, which is the single tasking system. In multitasking operating system, there are several tasks and processes that executes simultaneously. The OS is switched between tasks. Some tasks wait for events while others receive events and become ready to run. You can see this particular multitasking operating system in embedded systems is similar to that of the general purpose of computer system that we were talking about. If one is using a multitasking operating system, then software development is simplified because different components of software can be made independent to each other. The third thing that we can talk about is the rate monotonic operating system. It is a type of operating system that ensures the task runs in a system can run for a specific interval of time and for a specific period of time. So, you can see there is a focus on the time period. So, this particular operating system is meant for specific interval of time and also specific period of time. For certain seconds or for certain hours it will run, and then it will go into the quit position. When it is not ensured, there comes a notification of failures to system software to take suitable action. This time limit cannot be ensured if the system is oversubscribed. At this point, another event may occur during runtime and the failure notification comes. So, this is the limitation of this particular rate monotonic operating system. Another system that we can talk about is the preemptive operating system. A preemptive operating system is a type of multitasking operating system that interprets the preemptive predominance for the task. A higher priority task is always defined and run before a lower priority task. So, here the underlying word that you are coming across is the preemption. So, suppose if there is a queue of tasks to be done, so the higher priority task will get the focus, it will be done first, then comes the turn of the lower priority. Such multitasking operating systems are efficient in increasing system response to events and also simplify the development of software, making the system more reliable. So, here when we talk about this preemptive operating systems and embedded systems, there are some systems which have non-preemptive operating embedded systems. The designer of the system may be able to calculate the time required for the service interrupts in a system, and also the time is taken by the scheduler for switching the task from one process to the other process. Such systems may fail to meet the deadline of a system, and the software is unaware of the missed deadlines. CPU loading in a preemptive operating system may be measured naturally by defining a lower priority task that only increments counter and done nothing else. There is another thing called as the microkernels. A microkernel operating system includes only the bare necessities such as the task switching, scheduling and device handling interface in the operating system code. You can see here this particular microkernel approach is nothing but it is having a very limited functions. One is the task switching, another is the task scheduling, and the third is the device handling. Here you are not seeing various other functions when compared to the general purpose operating system. Then there is another operating system called as the monolithic operating system, and in the monolithic operating system this includes all operating system code such as device drivers and file system handlers as part of a single system image. So, whenever it loads into the RAM, it loads as a single system image. So, this particular monolithic operators, you can see the device drivers are also there, the file system handlers are also there, and they are part of a single system image. But in the when you take the case of the microkernel approach, these are missing. The device drivers are missing, file handling is missing, most of the IO handling is missing. So, that particular microkernel approach is having a very limited functionality, but in the monolithic operating system this particular whole package is treated as a single unit. So, that is the basic difference between the microkernel and the monolithic embedded operating system. So, let us see the requirements and specifications of an embedded operating system. So, a requirement is a condition needed by a user to solve a problem or achieve an objective. So, whenever we try to design the embedded system, the requirements are very much necessary. So, the requirements is nothing but we will be this is a kind of condition needed by a user to solve a problem or else to achieve an objective. But when you come to the kind of specification, it is a document that specifies in a complete, precise, verifiable manner the requirements, design, behavior and other characteristics of a system, and often the procedures for determining whether these provisions have been satisfied or not. So, in the specification we document each and everything, whatever the requirements that the embedded system wants to achieve. So, concerning upon the requirements or depending upon the requirements that the embedded systems is meant for, we design the specification document. So, this is a kind of technical document which fulfills each and everything, and it is the thing that will be coming into use for the software engineers. For example, a requirement of a car could be that the maximum speed to be at least 120 miles per hour. So, this is the requirement for the design. Coming to the specification, for this requirement it would be the technical information about the specific design aspects. Suppose if you want to design 120 miles per hour concerning to the speed, so what will be the technical things that needs to be taken care, and what should be the technical information that needs to be input in order to achieve the 120 miles per hour speed. So, requirements and specifications are very important components in the development for any embedded system, not only for embedded system, like whenever you are targeting for anything that needs to be automated, these particular requirements and specifications need to have certain level of focus. Requirements analysis is the first step in system design process, where a user requirement should be clarified and documented to generate the corresponding specifications. You can see you have to note down all the requirements, and correspondingly you have to take the specifications or else document the specifications also. For examples, errors developed during the requirements and specification stage may lead to errors in the design stage also. So, this is a kind of carry on forward. Suppose if something, if we are lagging, suppose if we are unable to record certain requirements, obviously that doesn't takes the place in the specification document also, which may leads to the improper design of the embedded system. So, everything is linked. So, the primary focus whenever we do the requirement analysis, we have to do it in a 360 degrees way, so that each and every requirement is taken care of, so that it will find the place in the specification document. Obviously, whenever you go for the design and other parts of the other phases of the software development life cycle, it will be very much through and a very good design, or else very good system will be developed. When this error is discovered, the engineers must revisit the requirements and specifications to fix the problem. So, in this particular session, let us recap what we had studied. We had seen what is an embedded operating system. We had seen what are the basic differences between the general purpose computer and then the embedded system, and what is an real time operating system, and then we had seen the types of non real time operating systems. We had seen what is the basic purpose of doing the requirements analysis, what is the requirement, what exactly is the specification. Suppose if some requirements are not being recorded, what will happen? All these things we had covered in this particular session. In the next session, let us focus on, in order to design an embedded system, what are the languages, tools and other software related issues. So, those particular things we will focus in the next session. Thanks for watching. Happy learning.